If you were given a problem like this on a test, what would you do to find the derivative of it? How would you find the derivative of the fifth power of sine of cosine raised to the fourth power of the square root of tangent of the natural log of x? Now, because we have functions within or inside of other functions, we need to use the chain rule to find the derivative of this expression. So before we work on this example, let's talk about how to use the chain rule. So let's say we have the composite function f of g of x. So g is inside of f. What you need to do is take the derivative of the outside part, that is of f, while leaving the inside part, g, the same, and then you're going to multiply that by the derivative of the inside function, so times g prime. And that's the process by which we could use the chain rule to find the derivative of composite functions. Now let's work on some examples to help you to see how to apply this information. Let's say if we want to find the derivative of x squared plus 5x raised to the fourth power. If you want to pause the video and try it, feel free to do so. So the first thing we need to do is we need to use the power rule. For instance, the derivative of, let's say, u to the fourth is going to be 4u to the third. So using the power rule on its exponent, we're going to have 4 times everything inside. We're not going to change what's on the inside. And then subtracting 4 by 1, we have 3. So you can think of u as the u variable as the stuff inside of the function. Now our next step is to multiply it by the derivative of what was inside the function. In this case, u prime. So the derivative of x squared is 2x. The derivative of 5x is 5. This would be the answer. So that's how you could use the chain rule when dealing with composite functions. You differentiate the outside part first while leaving the inside part the same, and then multiply by the derivative of the inside part. Let's work on some more examples for the sake of practice. Now let's try this example. Go ahead and find the derivative of tangent x squared. Feel free to take a minute and work on that example. So the first thing that we're going to do is find the derivative of the outer function, that is of tangent. The derivative of tangent is secant squared. So what goes inside secant squared? Well, this is going to be the angle of tangent. So whatever is inside of here, we're going to put it there. Next, we need to find the derivative of the inside part of the function, that is of x squared. The derivative of x squared is 2x. And so we could write the final answer as 2x secant squared x squared. So that is the derivative of tangent x squared. That's how you could find it. Here's another example you could try that'll prepare you for the problem ahead. Go ahead and find the derivative of sine tangent x cubed. Go ahead and work on that one. So let's start with the outer function, sine. The derivative of sine we know is cosine. Now, everything that is inside of sine, we need to rewrite and put it inside of cosine. So we need to rewrite tangent x to the third. So now we're done with cosine. Let's move on to the next one, tangent. The derivative of tangent is secant squared. Now the angle inside of tangent is x cubed. So that's going to be the same angle for secant squared, since secant squared came from tangent. Now the last thing we need to do is find the derivative of x cubed, which is 3x squared. And that's the process by which we could find the derivative of these multiple composite functions. Start from the outside and work your way in. So this is the answer for this example. So based on those three examples, you now know everything that you need in order to try this one. So go ahead and take a minute and find the derivative of that function. The first thing that I recommend doing is to rewrite the expression in a way that'll make this problem a lot easier. Now, one thing I want to mention is that, let's say if you have cosine raised to the 4 of x. This can be rewritten as cosine x raised to the 4th power. When dealing with the chain rule, it's easier to work with problems in this format as opposed to this one. So I'm going to adjust it accordingly. So cosine to the 4th power, let me highlight this in blue. This is going to be cosine, and then we have tangent. Now we have the square root of tangent, which is the same as tangent raised to the 1/2. So I'm going to put a 1/2 outside of the green brackets to represent the square root symbol. And then for cosine to the 4th, I'm going to put an exponent of 4 outside of the blue brackets. And then we have a 5 for outside of sine. So that's how we can rewrite this expression to make the work a lot easier. So what we're going to do now is we're going to take the 5, move it to the front. We're going to find the derivative of the outer part of the function. So if this was u to the 5th power, it would be 5 times u to the 4th power. So it's going to be 5, and then we're going to keep everything on the inside the same. So we have sine, cosine, tangent of ln x raised to the 1/2 raised to the 4th, and then we're going to subtract this by 1, so this is going to be to the 4th. So now that we've dealt with the outer part of the function, let's work our way in. So now we need to find the derivative of sine. The derivative of sine is cosine, and the angle of sine is everything that we see here. So that's going to be cosine tangent ln x raised to the 1/2. And we still have the 4th power for cosine. So now we're done with sine. We need to move on to cosine now. The derivative of cosine is going to be times negative sine. And the angle for cosine is what we see here. So that's going to be tangent ln x raised to the 1/2. Now I do need to take a step back. Before we can find the derivative of cosine, we need to work with this exponent first. So let's get rid of this. So starting with this exponent, moving it to the front, it's going to be times 4, and then everything that is in the blue brackets. So it's going to be cosine tangent ln x raised to the 1/2, and then we're going to subtract this by 1, so that's going to be 3. So now we could find the derivative of cosine as we work our way in. So it's going to be times, the derivative of cosine is negative sine, and then the angle of cosine is what we see here. So that's going to be the angle of sine, that's tangent ln x raised to the 1/2. Now, the next thing we need to do is move on to tangent. But before we do that, we need to work with the exponent. So it's going to be times 1/2, everything inside. So that's tangent ln x, and then 1/2 minus 1, that's a negative 1/2. So now that we are through with that exponent, we can work our way inside. The derivative of tangent is secant squared, and then the angle of tangent is ln x. Next, we could find the derivative of ln x, which is 1 over x. So that's basically it. That's how you could find the derivative of this entire expression using a chain rule. So this is the answer. Now you could simplify it or rewrite it in a more pleasant form, but I'm going to leave the answer like this. So thanks for watching, and don't forget to subscribe to this channel.